So chapter 2 starts with triangle congruence review, and later in the chapter we go into triangle similarity. But like I said, it starts with congruence review, so we should know this from integrated 1, so hopefully we get off to an easy start. So in chapter 1 you organize polygons into groups using their attributes and investigated relationships among different polygons. You found that two polygons that look very different, such as a kite and a rectangle, still share the common attributes of having four sides. But what makes two figures look alike? In today's lesson, you will identify congruent triangles. As you search for congruent triangles in today's problems, focus on these questions. What do we know about triangles? How can we show they're congruent? And what are the shortcuts for establishing triangle congruence? So one thing I will say before we get into this, and I always try and point this out because I think it's a big deal. When I was 14, 15, 16 years old, I always wondered why we spent so much time discussing triangles and what was so special about triangles as opposed to other shapes. But it did occur to me that I think triangles make up so many other shapes, and that has a lot to do with this. So if we can take our knowledge of triangles, that's quite a hexagon I've drawn there, and we can apply it to quadrilaterals or pentagons or to hexagons, then if we know about just the triangle shape, we can sort of use that knowledge to increase our knowledge of these other shapes. By the way, at this point a kid always brings up circles, but there is something known as the unit circle that does apply between a triangle and a circle. They have a lot to do together, and you will learn about that in integrated 3. Kind of cool stuff. But like I said, I just always like to throw out there that there is a reason we're talking about triangles, is because we're going to use this information to discuss other shapes as the year goes on. So recall that if two polygons have the same angle measures and side lengths for all pairs of corresponding angles and sides, then the two polygons are congruent, and there's a sequence of rigid transformations that maps one polygon onto the other. Again, congruent means same shape and same size. And there was 5 methods of triangle congruence that we talked about in integrated 1. So verify that all the corresponding side lengths and all the corresponding angle measures of the two triangles below are equal. What is a sequence of rigid transformations that maps the triangle on the left onto the triangle at the right? Well, first of all, they want us to understand 2 thoughts. One is the Pythagorean theorem, the idea that 16 squared plus 30 squared should equal the hypotenuse squared, right? The Pythagorean theorem. So if we do some math on this, we should recognize, and I'm going to go ahead and do this with the calculator, that 16 squared is going to equal 256, and 30 squared, I believe, is 900, right? So if I want the square root of 256 plus 900, that should give me the length of the hypotenuse. So the hypotenuse is 34. And again, the hypotenuse is always across in the right angle. So here, again, 16 squared plus 30 squared would equal 34 squared. The second thing besides the Pythagorean theorem that they want us to remember is the triangle angle sum theorem. And the triangle angle sum theorem says that all the angles of a triangle add up to 180 degrees. So here, if I just take 180 degrees and start, I know that's how many degrees in our whole triangle. I can subtract this 90, and I can subtract this 28, and whatever's left over must be angle T. And angle T would equal 62 degrees. And again, I can use that same logic. 100 minus 90 minus 28 would also equal 62 degrees. And there you go. I used the Pythagorean theorem to prove that all the sides are the same length. And I used the triangle angle sum theorem to prove that all the angles are the same. It looks like if I rotated this one over, kind of brought this angle up here and then translated it, it would fit on top. So just answering the rigid transformation sequences, again from integrated 1 as well. So it says write a triangle congruent statement for each of the triangles. Well, if you recall, there's a lot of different ways you can write a triangle congruent statement. The thing is, it doesn't really matter how you start, which is to say, if I say triangle TRI or if I say triangle IRT, it doesn't matter. What does matter is how I finish it. And what I want to make sure is that whatever angle matches up with the I is 28 degrees, over here the N is 28 degrees, so they need to be in the same spot. The R is the right angle, so I need to put the A because that's the right angle. And the T is 62 degrees, so I'll go with G over here. Again, if I said TRI, well, the T is 62 degrees, so the G would have to go first. The R is the right angle, so the A would have to go first. and the I is 28 degrees, so the N would have to go first. So you'll notice the I and the N are in the same spot. It doesn't matter if that's the first or the third spot, but they have to go together. Again, the R and the A go together, and the T and the G go together. So just make sure you remember that from Integrated 1 as well. So it says Luis wants to write a statement that the two triangles below are congruent. He started with triangle MNP, but got stuck because the triangles are not oriented in the same way. So complete Luis's statement form. So the one thing we want to remember is, up here it was easy because we knew what the actual degrees in the angle were. But here, to match up, right, the 62 and the 62 went together, the 28 and the 28 went together. But here, we don't have that same ability. So what we're going to do is, angle M, we're going to go with the side across from it. And you can see I get the 12. So I'm going to go over here to the 12, and you can see that matches up with the U. So triangle MNP is going to be congruent to triangle M is going to match up to the U. And now the N is across from the 6, so I'm going to go with the W is across from the 6. And then finally, obviously, the P is across from 15 and the V is across from 15. So again, just something that hopefully we know from Integrated 1 that if you struggle with, when we name these triangles, it's really important that if we don't know what the angles are, that we go with the sides opposite them. That's a big deal. So these triangles are drawn to scale. What sequence of rigid transformations would map the triangles from the left to the right? Well, it looks like if I rotated this one, that I would have the 6 on the side and the 12 on the top and the 15 on the bottom, and then I could just translate or slide it over. So both of them, it looks like a rotation and a slide. Yeah, they both look like rotations and slides. So it says the triangles below are drawn, so let me pause here and set up problem 2, 3. Okay, so the triangles below are drawn to scale, and congruent sides and angles are indicated with tick marks. So are the triangles congruent? If so, write a triangle congruent statement to explain how you know they're congruent. So, excuse me, a couple things. First of all, I know that this side matches up with this side, this angle matches up with this angle, and this side matches up with this side. So to me, this looks like side angle side congruence. Hopefully you guys recall that. The angle connects the two sides, here and here, and the A connects the S. So I would say, yeah, they are. Now it tells me to write a triangle congruent statement. So again, it doesn't matter how I start. I'll say NRL just to be a pain. But I know that N is across from 2 ticks, so I'm going to go with B, which is across from 2 ticks. I know that R is across from 1 tick, so I will go with C is across from 1 tick. And L has the arc there, so I will say A there. Okay, it says justify your answer in several ways. I don't understand what they mean by that, but I guess I could write another triangle congruent statement, maybe? I'm not sure. So let's say L and R. So, and I can just go L and R, 3, 1, 2, so I can say A, B, C. But let's go ahead and verify that that's right. Let's just say triangle ABC. L has a tick, A has a tick, so L and A go together. N is across from 2, B is across from 2, so they go together, and R is across from 1, and C is across from 1. So again, we feel pretty confident with that. Now it says in the previous course you investigated congruent triangles. Read the math notes box in this lesson to review the triangle congruence theorems. So that looks like this. We have these 5 triangle congruence theorems. Again, we learned all these in Integrated 1. We should be able to put these things in our note page. I have a place in the note page to write these things down. We have them in the 211 Math Notes book. Again, so there's no reason that we shouldn't know side, 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 where we have all 3 sides. Side, angle, side, where the A connects the S's and the angle connects the sides. Angle, side, angle, where the S connects the A's and the side connects the angles. Angle, angle, side, where the side doesn't connect the A's and the side doesn't connect the angles. And finally, hypotenuse, leg. A lot of people think that it just means you have to have a right angle. You need the hypotenuse, which means the side across from the 90-degree angle, and you need one of the 2 legs. So it's possible to have a 90, I can't write on this one. It's possible to have a right triangle that's not hypotenuse leg, but if you use hypotenuse leg, it has to be because it's a right triangle. So again, hopefully we remember these 5 from integrated 1. So we're going to try and prove that these things are or are not congruent triangles. And if they are congruent, we're going to write a triangle congruent statement. And we're going to say how we know. Well, look, this 70-degree angle connects the 8 and 11. So I would say that we definitely have side angle side congruence here. And I will make a triangle congruent statement. I'll say ABC is congruent too. It would be easy to say DEF. I don't know if that's right though. The A is across from 11, the F is across from 11. So we can see it wasn't correct. So it's always good to check. A is across from 11, B is the 70 degree, so E is the 70 degree. And then C is across from the 8, so D is across from the 8. As I go to B, you can see the sides are the same and there's an angle that's the same, but they don't correspond, and this is really important. Here, this angle connects these two sides, but over here, the angle that connects the two sides is this one right here. This angle connects these two sides, and you can see that's not the angle we have. So this one will say it's not congruent, or we don't at least know that it's congruent. We can't prove it's congruent. All right, if we go to C, hopefully we remember this stuff. And again, let me go ahead and pause this real quick. Couple things. The first thing I wanted to show you was the chapter 2 notes, and this is what I was saying, the triangle congruent statements. We should have these, maybe have an example of these. But the other thing I wanted to show you was how important it is that we actually learn this stuff. If I go back to the chapter 1 note page, you can see we have these parallel line relationships, right? These congruent relationships, alternate interior, corresponding vertical, and all that stuff. And it's not going away. So here you can see we have these parallel lines. Well, here's the transversal. That means that these angles are alternate interior angles. And if you'll notice, this is a different transversal, and these are different alternate interior angles. You'll also notice that these angles are vertical angles. So we actually know that all 3 of the angles are the same. So for sure we can prove all the angles are the same. Now the question is this side corresponding? So you can see between angle 1 and angle 3, we know it's side 6. And between angle 1 and angle 3, we know it's side 6. So yeah, we can say these triangles are congruent. And what's interesting about this is we can say it's true because of angle, angle, side. Or we can say it's true because of angle, side, angle. So either of these 2 methods would be correct, and I would have to accept either one of these. Again, though, we don't go side, angle, side. We don't break from one triangle to the next triangle. Sometimes kids say side here, this angle, this side. That's not how it works. You need to stay within this triangle and go angle, angle, side, or angle, side, angle. From there, we're going to have our triangle congruent statement. Again, it doesn't matter how you start. So let's say XMN, and we'll say it's congruent to X has 3, M has 1, so we'll say Z, and N has 2, so we'll say Y. And again, on this one was kind of interesting because we can prove vertical angles and 2 sets of alternate interior angles since we know these lines are parallel. Again, this doesn't say these sides are the same. It says these lines are parallel. All right, if we go over to D, hopefully we recognize that we have the reflexive property. Not sure if we remember the reflexive property or not, but maybe we want to mention that. The reflexive property basically says something is equal to itself. So that AD, that side AD is in this triangle on the left, and it's on this triangle on the right. Well, think about it. They have to be the same. Another thing would be this. A straight line is straight, and if this is 90 degrees, well, this must be 90 degrees as well. 90 plus 90 is 180. Again, we're allowed to assume that a straight line is straight. So now when I look at this, I can see I have angle side side. And angle side side spells a bad word and is not congruent, but it's a special angle side side because it's a right angle. So what we have here is the hypotenuse and one of the legs. The hypotenuse and one of the legs, a 90-degree triangle. So I would say yes, this is true because of hypotenuse leg congruence. Again, I can say triangle CAD is congruent to BAD. C is across from 2 ticks, B is across from 2 ticks, A is across from unmarked, A is across from unmarked, and D is across from 1 tick, and D is across from 1 tick, plus they're both the 90-degree angles. All right, E looks a little bit crazy. So again, don't forget, we have these parallel lines here, which means that this transversal means that these angles are going to be alternate interior angles. These angles won't necessarily be, because they're not alternate interior angles. They're not being pinched there by the thing. I don't really want to go too much into why they're not, but I guess the idea would be this. If you kind of look at this here, these ones are going to be alternate interior angles. But if we did something like this and something like this whole thing would be alternate interior to this whole thing, but this little chunk wouldn't necessarily be to this one. And I guess what I'm trying to say is, if I extend this double angle are alternate interior angles, but just this little chunk of it isn't necessarily to this little chunk of it. I hope I didn't make this worse for you. Every year I get a question on that where kids think that bigger angle it's just the smaller angle is. And then we have this reflexive side. So we do have angle side. So we have angle side congruence. And I can say triangle EFH is congruent to triangle E has one tick, G has the mark, F has the one arc, H has the one arc, and here H is unmarked and F is unmarked. So kind of interesting. A lot of times kids think that the H's have to go together in each triangle, but you can see here the F goes with the H and the H goes with the F. This F goes with this H, and this F goes with this H. So kind of some interesting stuff going on here. Hopefully you see it. On this one, we have a reflexive side for sure. So I would say it is angle, side, side. Don't say angle, side, because there's two sides in an angle, but that angle doesn't connect. It would have to be this angle here, and we don't have that angle there. So, yeah, I think what we're looking at is we're going to say it's angle, side, side, which spells a bad word, right? So it is not one of the ways of triangle congruence. You'll see if we look here, there is no angle, side, side. So we'll say not congruence, and we will leave it at that. Just to finish the chapter off, there is a theorem graphic organizer, but I would strongly encourage you to have these 5 down for sure for your notes. And I would also strongly encourage you to have, again, this filled in, and make sure you know what the reflexive property is. And again, don't forget that stuff that we talked about from chapter 1. That's going to be important as well.